Let's talk about the normal to a curve. There's going to be one new vocabulary this time. It's normal line, no new theorems or rules. So we begin with a definition, and it's the definition of a normal line. Normal line to a curve at a point is the line perpendicular to the tangent at that point. So let's review perpendicular again. First, graphically, if this is some line L, the perpendicular to that line, let's call it J, intersects line L at a right angle. That's the perpendicular. Also, as far as those lines go, the slope of the line that's perpendicular to the other one, perpendicular again, what a normal line is, has the opposite reciprocal slope. Opposite reciprocal. So that means if the slope of some tangent line were, say, 2/3, then the slope of the normal line would be -3/2. Okay, so let's keep that in mind and do an example. Write an equation for the normal line to the curve f of x equals 4 minus x squared at x equals 1. So let's begin with the formula that we know is used for the slope of the tangent line. That m tangent we know is the limit as h approaches 0 of f of a plus h minus f of a all over h. Now in this case, we're going to replace the a with x equals 1 because we know where exactly we want to find that point. So let's get started then. We have m will be equal to the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. So let's begin to simplify this. Limit as h goes to 0. F of 1 plus h is going to be 4 minus 1 plus h quantity squared minus f of 1. You plug a 1 into this function, we're going to have a 3 on the output. This is all over h. In my next step, I'm going to expand the 1 plus h quantity squared. So we have the limit as h goes to 0 of 4 minus 1 plus h quantity squared is h squared plus 2h plus 1, and then we're going to subtract a 3 again, all over h. Finally, let's distribute this negative sign into the trinomial h squared plus 2h plus 1 and simplify everything there in the numerator of this fraction. So we're going to have a negative h squared. We'll change colors here so we can see the work. Negative h squared. We're going to have a negative 2h. And then we're going to have a negative 1. But that negative 1 is going to combine with a 4 and a negative 3. So we're going to have 4 minus 1, that's 3. 3 minus 3 is going to be 0. So all of the constants essentially zero out. This is all over h. So then what we can do is factor out an h on top so that we can cancel it with the 1 in the denominator. So we're going to have the limit as h goes to 0 of, let's factor out the h, negative h minus 2 over h, and there we are. So this is going to end up with the limit as h goes to 0 of a negative h minus 2, and as h goes to 0, negative 0, so that's just 0, minus 2, we have an answer, negative 2. So there's the slope of the tangent line. I'm going to call it m tan. So what's the slope of the secant line? Well, the slope of the secant line then is going to be the opposite reciprocal. So let's go m, or not secant, normal line. The slope of the normal line is going to be positive 1 over 2. So we have the slope. Now we want to come in at x equals 1 and write the equation of that line. So what's the point where x is 1? Well, it'd be 1 comma 3, right? Because 4 minus 1 squared is 3. So let's go to point slope form. We're going to have y equals the normal slope, 1/2, times x minus 1, and then plus the y value, 3. While we're here, if this is the normal line, what would be the equation of the tangent line? Well, it'd be y equals, tangent slope is negative 2, times an x minus 1 plus, again, the y value, 3. So this should be our answer for the normal line. This is going to be our tangent line. And I think we should go to Desmos and see if we did well. So here's the graph of 4 minus x squared. I stuck a red dot at the point 1 comma f of 1. In this case, I use the name j for the function. So it's 1 comma 3. Here's what we said the tangent line was. All right, looks tangent. Good, good. And then here's what we gave our answer as the normal line. And there it is. So it actually does cut through the function, and it intersects the tangent line, and it intersects the curve at a right angle. So that's what we're going to do if we're ever asked to find the normal line to a function. And that is the end of this segment.